Weird. Hey, everybody. How is it going? My normally dependable camera's been acting a little wacky. The focus is going in and out. Keep an eye on it. All right. What's happening? To get the show ready. There we go. Okay, cool. I hope all of you are having a memorable Memorial Day. So last week, I should have mentioned this in advance. I totally forgot, but it was Victoria Day. And so I ended up not doing any work. So we all in Canada celebrate the birthday of Queen Victoria is a thing that we do. So anyway, I took the day off. The problem with being a Canadian is that we have to take off American holidays. We have to work American holidays because they're not in Canada. And we also have to work Canadian holidays because they're not American. And so we just end up working all the time when we're interacting with an international audience. So it's been a very strange thing. I'm sure a lot of you in other countries deal with that as well, which is like, if you're in any way interacting internationally, then you sort of have to take the average. I guess you have to. No, it's not the average. You have to essentially work. There's no such thing as holidays, is what I'm saying. So anyway, well, that in Canada doesn't have state-funded dental. No, we don't. Just medical. Is that why we celebrate Queen Victoria? I'm trying to understand what that's about. Yeah, it's like that. It's like that for everybody. Yeah. We all work all the time, forever. Yeah, cool. So, as always, the way we do this is I've got a bunch of prepared questions that I'm going to be starting with, and then once we get through those, we'll move into the questions that you're all asking live, and we will go from there. You just got the live notification. Oh, great. Okay. So that sounds like about 3 minutes is about the right amount of time to wait until we move forward. Okay, cool. All right. Well, let me get everything ready here, and then we will get started. Oh, right. I'll press record. Although I'm sure Chad has several reminders that remind me. Reminders. Okay, I am definitely recording audio. All right. Hey everyone, it's question show time. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I will gather them up and I will answer them here. Now, as always, I'm recording this show live. This time I'm on Monday, May 31st, 2021. So if some of the things that happen in space aren't reflected in the show that I'm doing, it's because I didn't know. I don't have a time machine. I can't see into the future. I just make bad estimates. But if you want to join us live for the show, remember, we do this every Monday, except for Canadian holidays, at 5 p.m. Pacific time on my YouTube channel. All right, let's get into the questions. All right, so we'll do the prepared questions first. Okay. JC. Hey, Fraser, love your work. Thank you. I'm wondering, what happens if a micro black hole passes through the Earth's core? Why would it not swallow the core and grow? Or if the density is the problem, I'm guessing one could pass through a neutron star and feed itself to a considerable size. Have we seen evidence for this? Thank you again for your amazing content. All right. So first, I think that, we have to sort of differentiate a few things first. So let's start with this idea of having a black hole at all. And the only way that we know naturally for black holes to form is via a supernova. And so you need to have a star with many times the mass of the sun, like more than 10, explode as a supernova. It then, all the material implodes down into the core, and it bounces off and creates this black hole. And you end up with a black hole that is several times the mass of the sun. And so if a black hole forming the way that we know they can pass through the Earth, I mean, really, it would be the most dominant gravitational thing in the neighborhood. As it passed through the solar system, it would be warping the orbits of all the planet. It would kick the sun, into a different configuration. It would throw out planets, it would throw planets into the sun, and it would eat planets. So having a black hole pass through the core of the Earth is sort of like having a truck pass through the core of a fly. I don't know. It's not really for scale. Now, there is a theorized kind of black hole known as a primordial black hole. And so it's possible that there were overdensities back at the beginning of the universe when you had these tiny little regions that were so dense that little microscopic or various sizes of black holes. I mean, you could have ones that are microscopic, you could have ones that are the size, the mass of a house, the mass of the Earth. And this is all still in theory. Nobody knows for sure that these things exist. But let's just imagine that there is one of these primordial black holes, a very small one, say with one with the mass of a house. So it's not enough to really disrupt the gravity of the Earth, that for some reason perfectly passes right into the Earth and heads down through the Earth. And so what would happen? Nothing. I mean, nothing. Because the gravity of a house is not that much. And when you have a black hole, it doesn't actually interact with the matter in any way. It's not like it's going to be bouncing, going to be slowed down. It's going to have its position change at all. So a black hole would be coming in at tens of thousands of kilometers per hour. It would pass through the Earth. It would burrow a tiny little hole in the Earth. It would add a tiny little bit of mass to itself. It would pop out the other side, and it would just keep going through space, never to return. And so if something like that happened, we would never know. Now, I'm sure you heard this disturbing theory that maybe when they first turned on the Large Hadron Collider, there would be this black hole that would be generated in the Large Hadron Collider, and it would fall into the Earth, and then it would consume the Earth from within. And that would be a problem because in this case, the black hole is trapped inside the Earth. I mean, think about it, right? When you drop something into the Earth, it can't get out of the Earth again. The most that it can do is going to fall all the way down through the Earth, reach the other side of the Earth, and then it'll be, it's going to speed up, go down to the core, then pass through, slow down, get right to the, right to the surface, like literally the same height as where it fell out of the Large Hadron Collider in Europe. I don't know what's in the antipode of Europe. And then it would fall back through the Earth, and it would be eating particles as it went, and then it would do it again and do it again and do it again. And so it would end up gobbling up the entire Earth from within. Now, it would take a long time, and eventually you get to this point where the interior of the Earth was just like Swiss cheese, and then the whole thing would just kind of crumble in on itself into this new black hole. And now the Earth would be replaced with a black hole with the mass of the Earth orbiting around the sun forever. So if we ever do form a black hole with one of our science experiments, we're just it's only going to be a problem for us. All right. Let's move on to the next one. Two-star. What happens if James Webb doesn't work? Not to the telescope, but what's plan B? If James Webb doesn't work, there is no plan B. James Webb cost all the money, and close to $10 billion. It's a one-off. They will never make another one. And if for some reason any one of its hundreds of actuators fail to deploy, if there's a problem with the upper stage of the rocket and it's pushed into the wrong orbit, if it crashes into the atmosphere, any number. I mean, if you think of all the ways that missions can go wrong, and any one of those things could happen to James Webb, and it would be the end for James Webb. But I can also imagine a bunch of in-between situations where, say, you get the upper stage doesn't fire as long as it's supposed to. And so James Webb doesn't get put into its correct L2 Lagrange transfer orbit. Well, maybe it's on a different orbit now that maybe NASA engineers could work with it. Or maybe not all the actuators open up, and so the sun shield isn't fully deployed and part of the telescope is overheating. NASA would try to figure out some way to work, get as much science done as they could. And of course, the other possibility, because James Webb is docked to the top of a Ariane second stage rocket, it's a very standard shape clamp. And so in theory, a future Starship or Orion capsule or Crew Dragon could fly to James Webb out at L2, dock with this docking port. It's got refueling ports built in, and they could try to fix or assemble or deal with whatever is wrong. So, but that's the kind of thing you cross that bridge when you come to it. So let's just assume that there's not going to be any problem. James Webb is going to fly. It's going to reach its L2 point. It's going to deploy nicely, and it's going to go to work exploring the universe. And if there are any problems, then hopefully NASA and its partners will be able to work with the ingenuity that they show all the time every time missions go wrong to try to save it. And then sometimes, as we saw with eventually Kepler, as we saw with InSight not being able to deploy its probe, sometimes you just can't fix the problems and you have to call the mission a failure. And if that happens with James Webb, they won't build another. The needs have moved on, the community's moved on, the designs are complete. It's just not worth it financially to go and just build a brand new one from scratch. So let's hope for a success. Hein Duplessis. Can Oort clouds overlap? If two stars are closer to each other, can their Oort clouds interfere and overlap? Sure. The Oort cloud of the sun, of the solar system, is surprisingly big. Our Oort cloud goes out about 50,000 astronomical units, which is about 2 light years, which is about halfway of the distance to the nearest star, to say Proxima Centauri. And so you can imagine if all star systems do have Oort clouds, these are of course the source of the long period comets, this giant cloud of ice that surrounds the solar system. If every single star system has these, then you can kind of imagine like the Oort clouds overlapping all the time. And it, probably nothing ever happens. I mean, they're a distance, when you imagine the volume of a sphere that goes out to 2 light years and the number of objects, the distance between those objects is just going to be enormous. So the issue is when, it's not really a problem of the Oort clouds interfering with each other and overlapping. It's when you get a star going through the Oort cloud. And this happens all the time too. We're probably, someone did the math that we're going to get a star that's going to come within something like 240 light days. Maybe it's 24 light days. Anyway, going to come within dozens of light days of the Earth over the next few million years. And so we get close flybys of other stars every few million years. So you can imagine a star passes right through the Oort cloud and disrupts it with its gravity, flinging comets out, stealing comets, and throwing comets inward. And it's thought that these close flybys of other star systems might be one of the reasons why we have rises in extinction events, why we have various periods where it seems like there was more comets blasting into the inner solar system. Could be stars passing through our Oort cloud, and we pass through other stars' Oort clouds. So it's kind of inevitable. It's kind of weird to think about. All right, those were the questions that I had prepared. Let's see. Horizon Brave, have I read Project Hail Mary by Andy Weir? No. I tweeted at Andy, but I need to schedule a time to read his book and have a conversation with him. But weirdly, I don't know, I've clearly become pretty lazy because normally I just wait for the publicist to reach out to me and say, here, do you want here's some new, all the books behind me, right? Here's a new book. Do you want to review it? Do you want to interview the person who's doing it? And so, but this one just came right under the radar. So I'll have to reach out to Andy and see what I can do to get in touch with his publicist and get a copy of the book and read the book and then interview him. So I'll do that. Thank you for the reminder. I mean, I've already interviewed him twice. So it's like we're old friends now. Hamachingo, if billionaires got together, bought most of the gold and ground it up and just released it into low Earth orbit so that it rains down in trace amounts over the equator, would it reset the world economy? It would reset the world economy and the cost of space flights. Is gold, let me think. I haven't done the math here. What is the price of gold per kilogram? What's gold per kilogram? So gold is $73,000 a kilogram Canadian, while trips to space are, say, $10,000 Canadian. So it would be financially, it wouldn't cost more than the price of gold to launch gold, but it would be pretty close. So you could just launch rocks and reset the world economy if you needed to. And then, of course, if you did, then the gold would incinerate as it passed through the atmosphere and would just turn into gold atoms, gold ions. So it wouldn't be raining gold. And even if it did, how would you catch it? I don't know. I don't think it's going to be a feasible idea. Vanjay Bernazzo, what is the best TV show ever and why is it for all mankind? I don't have Apple, and so I can't see For All Mankind. I got to wait for my wife to buy a new iPhone before I watch it. Nifty's, will the Canadian arm be okay? I think it got hit by something. I haven't heard that. Okay. Archon Wu. Does China consider colonizing Mars a priority? We don't know what China's long-term plans are for spaceflight beyond more, faster, better technology. I mean, where we are today in 2021, China now has sent many missions to the moon, landers, rovers. They've done a sample return mission from the moon. When you look at the logo of their lunar program, it's a little boot print in the moon. So clearly the plan for the moon is to have humans, have Chinese astronauts, taikonauts, go to the moon and walk around. At the same time, now we know that the Zhurong rover is down on Mars. So we've got a Chinese Martian rover, and of course that'll probably lead into more rovers, sample return, orbiters, etc. That seems like it's kind of inevitable that they're going to eventually make their way to sending humans to Mars. Will they colonize it though? I don't know. I don't think, I've been on the record in that I don't think anybody's going to want to colonize Mars for a long time. We're going to have science stations on Mars, and the Outer Space Treaty allows various countries to build research stations with various rules, but to actually colonize and claim territory, no one's allowed by international treaty to claim any territory outside of the Earth. And so you actually can't own any part of Mars, the moon, whatever. You can build a base, but you have to let anyone who wants show up and stay in your base. So the rules out in space right now as part of the international community don't work in the way that a lot of people think they work and how they work here on Earth. I think we all have to be shown that that there's some viable reason for human beings to want to live on Mars for long periods of time. And I've mentioned this in the past, that I really liken this to human beings wanting to live in Antarctica for long periods of time. We go there for science, but all the various times that people have gone to Antarctica to try to live, they've failed because it's awful. It's really, a bonus, penguins. Downsides, bitterly cold, nothing grows, nothing to do. So I think we're going to see something similar to that until somebody figures out a good reason to live on Mars. So I don't think anyone's thinking that far in advance. Okay. Fugal Creations. Do you think that a stable, habitable world could exist around a 2 or 3 star system? This would be epic. Tatooine for the win. Yeah, absolutely. You could definitely have a habitable planet orbiting around a multi-star system. So 2 stars, 3 stars, 8 stars, no problem. All of these configurations are possible. Now you need to have there's 2 ways that you can have habitable planets that don't get kicked out of a multi-star system. If you've got like 3 stars that are very close to each other, or even 2 stars, and you've got planets that are trying to orbit very closely to those stars, the gravitational interactions between the stars and the planets are going to kick out the planets, they're going to consume the planets. But there are configurations where the planets and the stars can be stable. So the one configuration is where you've got, say, 1 star and it's got it's like a little solar system going around it. And then really far away, say 10 astronomical units, 20 astronomical units, you've got another star. And so the 2 stars are sort of orbiting around each other, or 1 star is larger and the other one's orbiting around it. The other configuration that you can have is where you've got 2 stars that are orbiting around each other really closely, and then you've got the planetary system farther out, say 2 to 4 times the distance between those stars. And if you've got that situation, then it can be stable. And then you can imagine various combinations. So you could have, say, 2 stars in the center with a bunch of planets going around it, and then another star orbiting way far away. As long as that's all stable, that's just fine. And that other star could have multiple planets orbiting around it. And then you could have 2 stars over here, and they're orbiting around each other, and they've all got planets, and then 2 stars over here, and they've got planets around them, and that's all, and they're orbiting around each other, and that's all stable. And then you could have more, as long as you just sort of continue that way of nesting stars and planets around each other so that everything is stable. In most situations, you're going to get planets getting kicked out, but definitely there are stable configurations that could be possible. So Tatooine is absolutely, there are definitely star systems out there in the Milky Way where you could be on a planet with liquid water and be looking at multiple stars in the sky, multiple suns. Oh, there you go. Okay, so Nancy's saying the ISS was stuck by debris. There's a hole in the Canadarm. Yikes. Okay. Cryptolicious, what are the rules like? Were you asking about the Outer Space Treaty rules? Lillian Brennan, do we name black holes? No. Black holes, there's no official name. Like the black hole at the center of the Milky Way is called Sag A star. And then typically the black hole will get some numerical designation that corresponds to some catalog. But we don't name them. We should. We should totally name them. In the same way that we name... astronomers don't name a lot of things like quasars and, newly discovered stuff. Don't really name exoplanets. Stars have names, and in fact, a bunch of stars got names in the last couple of years. Asteroids have names. Comets get names. Comets are named after the people who discovered them. But most astronomical objects don't get names. Let's see. All right, I'll do this as a continuation. Robert Shaw. Do you think that the United States will take China seriously at the beginning of this new space race, or will we all be too busy with their own internal politics? I mean, I guess, a lot of people are saying that now with China being so serious about space exploration, that this is going to usher in a new space race. And I don't think that we're really going to see a new space race. I think China is definitely going to put feet on the moon within the next probably decade or so. I mean, they're really building up to it. They've got a space station at this point. They've got astronauts who've flown to space. They're demonstrating their ability to send missions to the moon, be able to return them safely back to Earth for sample return. They've built rovers, landers. They've been able to go to the far side of the moon. They've been able to send missions out to Mars and land, which is notoriously difficult. So I think it doesn't seem unreasonable that we're going to see a human mission, a Chinese human mission to the moon at some point in the near future. But I don't, but at the same time, and we see like Starship with SpaceX is planning to put a lander on the moon shortly, completely independently. We know that there are other missions. There's like conglomerates, I think like Northrop Grumman and a couple of other aerospace providers were planning to be able to do their own private mission to the moon. The European Space Agency is planning to build some kind of moon village. What's happening is that the technology is bringing the prices down, bringing the reliability up, and so it allows a lot more opportunity to be able to go to these places. It's kind of like, back at the beginning of the 20th century when the Wright brothers did their first flight, and then you can imagine that first flight and then a few other people figuring it out, and then people saying like, do you think this is going to cause a new air race? Will China be the first to fly people to another continent or whatever? And it's just like suddenly it stops being this one-off thing that people are spending enormous amounts of money to accomplish and just turns into this thing that's more and more routine. And so I think we're all of the really low-hanging fruit, the first humans walking on the moon, the first human in space, they're done. They're gone. There's no real advantage to making that achievement if you can't sort of sustain it and move forward without some reason why you're doing this. There's still one sweet prize remaining, which is that first human who walks on Mars and returns back. That will be really exciting. Beyond that, I think we're sort of out of it being a race and now just being into just the future of humanity is utilizing space. And like, who's winning the airplane race right now? There's just so many airplanes flying all the time into all these different places, doing all these different jobs. That's what the future is going to look like. And so I don't really see this idea. I'm not really sold that it's going to be a race from this point forward. All right. Is my phone talking to me? Okay. Yes, China is, Lionel, yes, China is a signatory to the Outer Space Treaty. So is Russia. I mean, they can always pull out if they want. What is the refractor behind me? It is a 80 millimeter Stellaview. God, the poor Canadarm. Mark Carter. Okay. Actually, I don't officially know the answer to this. I'm not going to do this as in the question show. But Mark Carter's asking, will Starlink cover the South Pole? I mean, Starlink's going to cover the North Pole, so I assume it's going to cover the South Pole as well. The problem is there's no ground stations near the North Pole, and so the Starlinks are going to be configured so that they can send laser signals to each other to communicate and to be able to chain their communications around the Earth and back to ground stations. So I'd assume they're going to do the same thing. And the reality is that having the Starlinks communicate with each other in space is actually a lot more efficient and faster, because the speed of light in a vacuum is much faster than the speed of light going through a fiber optic cable. So it turns out if you want to send a signal from one side of the Earth to the other side of the Earth, the fastest way to do it is to go up to a satellite, chain along satellites, and then come back down to Earth. And so they're going to be testing out this technology over the poles, but I'm sure eventually we're going to see all of the Starlinks communicating most of the time, chaining along from space before they come back down to ground stations relatively nearby. Or never? Anyway, yeah, that's the fastest way. That's the future. Okay. All right, I will do this one. Sure. Sierra Vortec. Do Guy think we are the actual dark matter and that the other 85% of the universe is filled with dark planets and dark suns and invisible people? Okay. Are we the dark matter and that the rest of the universe is dark planets and dark suns and invisible people? You broke my brain. All right. So I guess the question you're asking is, do we think that the rest of the universe, I mean, we know that, say, most of the matter in the universe is this dark matter, and we don't see it, and it's invisible, and it doesn't interact with regular matter in any way, shape, or form except for gravity. And so, but do we think that it's dark planets and dark suns and invisible people? No. We think it is some kind of particle, a soup of particles that is evenly distributed across regions in the universe, and it doesn't interact with itself. We know that it doesn't interact with itself. And so when you think about people, we interact with ourselves. We're held together by our chemical bonds. We think about a planet is held together by the gravity pulling it inward, as well as its various chemical bonds stopping it from collapsing into a black hole. But for some reason, dark matter, whatever it is, doesn't interact with itself. It doesn't interact with us, and it also doesn't interact with itself. And so it wouldn't be able to form into planets and stars and people. It would just be particles passing around each other in the universe. That's our current understanding of what it is. But, we still are waiting for some kind of concrete idea of what dark matter is. All we know is that it's there. And we know a few of its characteristics, but we don't know what it is yet. But that's fine. I mean, that's how mysteries work. You start with a mystery, and then you start to try and figure out what it is. If all the answers were provided to you, then life would be kind of boring. So appreciate the mysteries and enjoy as we follow along as we try to figure out what they are. What do I expect from the soon-to-be-released Alien files? I don't know. I'll take the question, though. Sure. You paid money. Thank you. Helmut Bemboka. What do you expect to be... Oh, let me do this again. Helmut Bembuka. What do you expect from the soon-to-be-released Alien files? I'm not sure exactly what this is. I'm assuming this is like some kind of official release from the U.S. government about the various unidentified flying objects that they have been observing across the decades. What do I think is going to be in these news releases, these releases from the government. Well, I always sum up UFOs is somebody saw a thing. And so I'm expecting a bunch of examples of somebody. It could be an amazing camera system, a renowned expert, fighter pilots, radar operators, satellite antenna. So somebody saw, imaged, radar signaled, infrared scanned a thing. And it'll be like a blob, a dot, a blur, something. And it's just going to be that. Every single thing that will come out of this information will be somebody saw a thing. There will be no way for us to walk over to the thing, to meet the inhabitants, to be able to take a sample away, to be able to take it to a lab and try and figure out what it is, to be able to travel to its current location and orbit around it. None of those things will be possible. And so I think it will continue to be unidentified flying objects. And whether they turn out to be weather balloons, Mylar party balloons, whether it's Venus, Jupiter seen with an unfocused lens, whether it actually turns out to be some kind of advanced propulsion system being used by other countries, that would be kind of amazing if they had some kind of evidence for that. But yeah, no, I think we're gonna have as little information as we did before, and we'll continue. Somebody saw a thing is what you could just boil down every single one of those things. And so if it's like somebody saw a thing, when someone comes up to me and they're like, yeah, well, like, what do you think? What do you think about this news report about that thing that this person saw? And I'm just like, I can't do anything else. Like, can I get in the spaceship? Can I borrow their ray gun? Can I shake hands with the alien? Let me know when I can. And until then, it's a UFO. It's unidentified. And it flies. And it's an object. So, yeah, I think it will be it will be not interesting, unfortunately. I know there's so many people that are waiting. This is it. This is the moment. This is the conclusive evidence that we have that there are other nations on Earth who have advanced propulsion systems and they are routinely flying in our skies. This is the moment that we discover that Earth is part of a giant federation of planets and they've been sending scout craft to our planet all this time. This is the moment when disclosure happens. And it's not. It's just gonna be as inconclusive as it's ever been. I'm sorry. So just remember, somebody saw a thing. All right. Noah Farnsworth. Empowered Path Chiropractic. Why are traditional news outlets fronting like they believe in ET UFOs? Who's to say that they don't believe in them? It's possible that they haven't spent as much time looking in the sky and seeing the actual kinds of objects that people routinely confuse for UFOs. It might just be that they know that there's a real hunger for this kind of information. And so there's lots and lots of people who are going to watch the news program and read their articles. And then they're going to forget that they didn't get any answers. They're just going to move on. And so, yeah. Okay. Some more here. Ratings. There you go. Ratings. That's why. Yeah, are you kidding? If I wanted to make more money, I would just do UFO videos all the time. That's interesting. Okay. Nathan Conklin. I'm an astronomy hobbyist interested in a deeper education. I've taken an intro to astronomy course at university, but I'd like to go deeper. Where should I go next? I'm looking for structure. It's a bit of a tricky one. It sort of depends on what you already do. Like if you already have a background that integrates nicely with space and astronomy, then there's a lot of interesting options. Like if you're a computer scientist and you do lots of work with gigantic databases, then there's probably lots of work that you could do to be able to interact with astronomers once you understand the basics. But if you have some non-science career, existing career, something that's just like more tangential to that, and you just want to start learning more about astronomy, there's a couple of options. One is there's like online courses you can take that'll let you do a master's degree in astronomy. So if you already have some other degree in something unrelated, you can spend 2 years online. Like Swinburne does it out of Australia. There's a few others, I think, out there where you can get, say, a master's degree in astronomy and then use that to connect over to something else. But if you're looking for a structure, it depends on whether or not you're looking for a job. Like if you want a job as an astronomer, then you have to go the traditional route. You have to get your bachelor's degree, you have to get your master's degree, you have to get a PhD, you have to produce papers, you have to work as an advisor, you have to apply for jobs at either research universities or other places and hope to get a job and become an astronomer. And it's a 10-year path to get from when you start taking your classes to when you're ready to look for jobs. So you've got to be really serious. And there aren't a lot of jobs. You're looking at 200 applicants for every one position that's available. So your chances of getting a job as an astronomer are very low. And so people always ask me, like, I want to be an astronomer, should I go to astronomy? I'm like, take computer science as well, because there's a million jobs for that. And if you can't get in as an astronomer, you can always get a job at, Google. You can always settle for a job at Google or Facebook or something like that. But if you just want to learn astronomy in a structured way, and if you're a self-starter, then I would build my own astronomy curriculum. And there's a guy, and I forget his name, and I apologize, but I'm pretty fascinated. He built his own computer science degree in about a year's work. And so he sort of built his own curriculum. You can now find websites that'll let you build a curriculum for creating essentially your own degree. All the textbooks that you need. A lot of the stuff's available online now. There's tons of stuff out of MIT and other universities that you can go and take their classes, see the professor lectures, do the problem sets, really just simulate the whole process of getting a degree in astronomy, as long as you have the discipline to be able to do it for yourself. So that's what I would do if I were you, is like I would sit down, try to either find someone who's already done this, but synthesize an astronomy degree from a bunch of different places. Go, okay, what is the typical list of courses that you have? Introductory to astronomy, the various math classes, the various physics classes that you have to do. Build a curriculum, and then find online versions of those various courses, get the textbooks, get the problem sets, and make your way through that list. And my guess is, if you're reasonably disciplined, you could go through a 4-year degree in a couple of years. Now, you won't get recognized for the work that you do. You can't turn that into a career afterwards. But if you just want to have the knowledge, that's probably the way that I would go. The other thing that you can always do is you can get involved in various citizen science projects. So there are plenty of astronomers who would love to get your help with, say, confirming exoplanets. You don't need a degree to be able to do this, or what we do with CosmoQuest in identifying craters, counting rocks on asteroids, things like that, galaxy zoos. So there's lots of other citizen science groups that you can get involved in and not need to go through that whole degree process. So I would sort of figure out which way, and if you want to respond back, we can, I can give you some more guidance, but sort of that's the landscape that I think you're looking at. Arjone, shouldn't there be a few supermassive black holes around Sag A star? Since the Milky Way has been eating other galaxies, would they be hard to find? Now, Sag A star, that is the supermassive black hole at the heart of the Milky Way, more than 4 million times the mass of the sun. Where are all the other supermassive black holes that the Milky Way gobbled up? Well, actually, there's some pretty recent research that came out in the last couple of days that new simulations say that the Milky Way probably formed fairly slowly over long periods of time by consuming lots of smaller galaxies and not like a really big collision with another galaxy. Like when we collide with Andromeda in whatever, 7 billion years from now, it's going to be big galaxies coming together, huge supermassive black holes coming together. It's going to be crazy. But the kinds of interactions that the Milky Way has had in the past has been with dwarf galaxies. Some might have had supermassive black holes in them or intermediate mass black holes. Some maybe didn't. We're still not sure exactly how many of them out there do. When supermassive black holes interact with each other, they tend to find their way down to the center of the galaxy and then will interact with each other. They'll orbit around each other and then merge. And so where did all of the other black holes go? They joined Sag A star, or they were kicked out of the galaxy and are now roaming around deep space. There are supermassive black holes without a galaxy, just roaming around the universe. Enjoy. Okay. I actually have a plan. I'll regarding the course. So I have a plan for astronomy course that I want to do. I'll run this by you now since you're, this is a safe space. So my plan is I want to take a curriculum, like kind of what you're describing. I want to sort of like history of astronomy and black holes and stars and all the various parts that would form a astronomy curriculum. But instead of like having it be lectures, kind of like what Crash Course did with astronomy, I want to do it in the form of an interview. So I want to line up like do an episode on the Greek astronomers, and then I want to find an expert in Greek astronomy and interview them in a very kind of like Astronomy Cast. But while Pamela is very much a generalist, I want to find a specialist, but have it follow a structure. And you can kind of listen to each one of those episodes and build up an understanding of astronomy in a very sort of rigorous, structured way. That was my idea. I'm sort of thinking about this. And so it just means lining up like 50 different people to do interviews with and then follow a structure as I go through all those episodes and have it just be one big, call it Astronomy 101, right? But in a very non-traditional way of it working. So that's the idea that I'm sort of rattling around in my brain. But it sounds like a lot of work. Michael Maxwell, do I believe in ghosts? No, I do not believe in ghosts. Mr. Mann, what would you say if you actually met an alien? Hello, nice to meet you. I like your hat. That's a good start. Are you kidding? What alien wouldn't like to have their hat complimented? I'm sure they're very proud. They wouldn't wear their hat if they weren't very proud of it. And so for me to just open up with, I like that hat, that's a winning alliance right from there. All right, let's see this one here. Cryptoman 5000. Have we measured how fast gravity travels? We have measured how fast gravity travels. In fact, that best measurement for the speed of gravity was actually just done a couple of years ago with the Kilonova event that happened in 2017. So what happened was you had these two neutron stars that were orbiting around each other, closer and closer together. And in the last few seconds, they buzzed up really close to each other, released a mountain of gravitational waves, and then collided, and then it detonated in radiation. And so here on Earth, we detected the gravitational waves as the two neutron stars were starting to come together, and then exactly the moment when the two stars should have collided with each other, we saw the beginning of the flash, of the radiation, of the explosion. So the gravity waves came to us at the speed of gravity, speed of light. The radiation from the explosion came to us from the speed of light. And so we knew, sort of conclusively proved, that gravity and light move at precisely the same speed, the speed of light. The speed of gravity, I guess. The speed of gravity light. The speed of light gravity. Okay. Joe Revelle. When will James Webb become fully operational? So James Webb is due to launch October 31st, 2021, although it looks like there might be a delay because there's some issues with the Ariane 5 rocket. There's 2 previous missions had problems with the deployment of the fairings of their missions, and that's, not surprisingly, made NASA a little freaked out. And so they're having another look at it. And so while James Webb itself is done, it's finished, it's been folded up for the last time, and it's ready to make the journey down to the launch site, they might want to take a little more time just to make sure that rocket is working perfectly. Once it does launch, it'll take not long, a couple of days, to get out to its final home in the L2 Lagrange point. And then it's going to take about a month to unfurl itself, to fold out that sun shield and to fold out all of its mirrors and all of the other parts of it. And so it'll probably not be delivering first light for about a month, a bit over a month after it launches. So we all have to be very patient. But it'll launch. It's going to work. All right, let's see what's 52. Let's see. Grab one more. Man, I don't know what the wind speeds are on Titan. Let's find out. Wow. I don't know what the wind speeds were on Titan, but the wind speeds on Titan were 400 kilometers per hour at the upper atmosphere, but I don't know what they are at the lower atmosphere. So you're asking a question. Where was it? Yeah, Vandre Brunazzo, how bad are the weather and chemical composition? The atmosphere on Titan for Dragonfly, do they have to specifically design it to survive storms at denser atmospheres? I don't know the answer to this question. I'm sorry. I don't think it's a problem at the lower atmosphere, but I don't know the answer. So I'm mentioning this because I'm now going to research it because I want to know the answer. Mutter Hat, you're late, but that's okay. I'll stick around for some bonus time afterwards. Cryptolicious, if the craft are not aliens, then are they spy drones? Which is worse? Well, I mean, the most likely answer is that they're neither aliens nor spy drones, that they are Venus, Jupiter, weather balloons, a misidentified object. So what would be worse, aliens or spy drones? I would say aliens would be worse. If I had to pick one, another nation has the ability to spy on citizens. Okay, that's, it's a little troubling. An alien civilization has the ability to send spacecraft across the vast gulfs of space to our planet, and they haven't bothered to introduce themselves. It seems a little unnerving. I'd choose spy drones over aliens personally. Richard Patton, do you think that our AI will explore deep space, including alien worlds, and not us? No meat robots needed. Yeah, I mean, when you think about how fragile and short-lived human beings are compared to robots that we build, robots theoretically can last for thousands of years. They can handle G-forces that would liquefy human beings. They can handle high amounts of radiation and temperature. They can handle the vacuum of space. They don't need food. They don't need water. Like, all they need is a little bit of energy and a way to to radiate heat. It seems like the best thing to send to another world is a robot. And so, yeah, absolutely. The vast majority of the exploration of the entire Milky Way, when we get to building our von Neumann probes, where we're building robotic spacecraft, and then those robotic spacecraft are building other robotic spacecraft, and we're sending them from world to world, and they're just going to be sending back what they find to us here on Earth. And it might be that after thousands of years, tens of thousands of years of this exploration of the Milky Way, our robots find some really juicy planet, some place that's just like a super Earth that happens to have the right temperature and pressure and has like really nice conditions on it, but it doesn't have hostile life forms on it. Then we might maybe consider sending humans in some way to that. Maybe we'll send DNA factories that'll go to that world and try to terraform it and populate it. But unless we come up with some kind of exotic propulsion system, stargates, warp drives, wormholes, until we can figure that out, we're going to be stuck to the solar system for the foreseeable future. Sop with Camel says, I will never underestimate the human ability to take anything for granted, including discovery of life. Human psychology does not change. I totally agree. People always ask me, what would happen if we found life in the universe? I'm like, not much. We would be excited for a little while, and then we'd be bored, and then we'd go back to doing what we do and see what's on TV and play with our phones. And it's not like we would just spend our time in just majesty, contemplative majesty over the stunning place we find ourselves in, this transcendent universe. We'd just be like, hey, did you hear they found aliens on Alpha Centauri? They're literally waving to us. Cool. Wow, that's crazy. Wave back. What's on TV is how that'll play out. Chris Sender, are you going to get any sleep during James Webb launch? No. Larry Beckham, any news on SN16? Not that I know of. They did a road closure last week, but didn't really see anything interesting happening. All right, I'm going to wrap up the show, but then I'll stick around and answer some other questions. So let me just do the Patreon bumper. More questions in a second, but first I'd like to thank our patrons: William Mason, Ken Nadziela, Daniel Morrison, Thur 1994, and the rest of our 843 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And then I'll do the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. Okay. All right. I'll stop the recordings. That one. Okay, cool. All right. Let's see. Yeah. Tony J. Hi, when will disclosure happen? Disclosure of what? Disclosure of the aliens visiting our world? That would take them, there actually be aliens visiting our world. So, I'm not holding my breath. Giovanni Falmouth, we're leaving the solar system before 3000. I'm calling it. Okay. Yeah, I don't, well, I mean, we, like the human beings, like just the meat is going to be leaving the solar system, or our robots? Because I definitely think we'll be sending our robots before the year 3000, but to send our fleshy bodies, I can't imagine. Like, unless we develop warp drives, wormholes, stargates, we're not going to be able to do it. Matter Hat, who's up for a lander and a rover to the dark side of Mercury? Well, Mercury doesn't have a dark side. It doesn't even have a far side. Mercury does turn. But me, yeah, absolutely. Mercury for the win. Come on. Now, Mercury does have permanently shadowed craters in the same way that the moon does, and permanently sunlit areas on Mercury as well. So you could go to places, and actually there would be deposits of water ice on Mercury, which you could use for fuel and astronaut bases and all kinds of things. So yeah, we should totally go to Mercury. I think it's great. It's a fascinating world. It's just constantly forgotten. Gordon Chin, what animal do you think will succeed us? Oh man. Like, obviously I'd go for the dolphins, but then the dolphins are stuck in water, so they can't make fire and stuff. The octopuses? I'd go with the octopus. I think the octopuses are the ones that are pretty clever, so I think they're the ones. Leo Schultz said, the aliens will say that your taxes are overdue. Yeah, we join the Galactic Federation, and the aliens will show up right away looking to collect our taxes. That sounds about right. That's why they're here. They're here. They're performing an audit right now, and then when they're done, they'll tell us what the bill is. Cryptolicious will have an antimatter drive propulsion within 100 years. They will be fast. Maybe. Antimatter is pretty difficult stuff to produce. Right now it's like $68 trillion per gram. Now, sure, maybe the prices will come down, but at the end of the day, you're having to generate antimatter levels of energy to be able to store it as antimatter. Like, there's no way around this. Like, if you want to have, I don't know, X amount of kilowatt hours of antimatter energy, you have to generate that energy first to create the antimatter, and then you've got to have it in some kind of containment bubble to keep it away. But sure, maybe. But then if you got up to those kinds of speeds, like if you went really fast, then, we've talked about this in the past, that you would be like grains of sand would be hitting your spaceship like little bombs. So you're gonna have to generate some kind of force shield, and so maybe you're gonna build a warp drive, and like it's all just so far into the future that we just don't know. Like, we still haven't had humans walk on Mars yet. We haven't gone back to the moon in like 50 years. So yeah. Romulus XC, would you prefer going to Ganymede or Titan in terms of colonization? Don't make me choose. Okay, so let's see what they got going for them. Titan has like 1.5 Earth atmospheric density, so you wouldn't need a spacesuit. You just need a coat. But you could like walk around, but the ground is like, you've got this weird methane seas to explore. It would be fascinating. Ganymede has its own magnetosphere. It's like the only moon with a magnetosphere. Titan. I have to choose. You made me choose. I choose Titan. Horizon Brave. The temperature of the planet's core, is there any relation to their size? Bigger the planet, the hotter the core. Yeah. The more massive the planet, the hotter the core. The core of the Earth is like 6,500 Kelvin, while the core of Jupiter is like 90,000 Kelvin. So yeah, the more massive the planet, the more pressure is heating up the interior, the more it holds on to its heat, and the hotter it's going to be. Yeah, peaks and pokes. Yeah, can you 50 years since people on the moon next year? Yeah, 50 years since the last people on the moon, not the first. Like the last human to set foot on the moon next year, it'll have been 50 years. That's where we are. Chungo, UAP, question mark, question mark, question mark. Like, what are they? I think, we did a video a couple of weeks back with Mick West, which is called Identifying UFOs. And we talk about all the work that Mick has done into identifying UFOs, UAPs. And so far, they all seem to have fairly mundane answers. They're clearly gimbaling camera systems. They are out of focus. Night vision goggles and various other explanations. So, but even if we can't explain them with something that we know, then they just are unidentified. And you can't, as I say many times, you can't identify yourself. You can't unidentify your way to knowledge. Like, it's just in the name, unidentified. So until I can get inside the spaceship, until I can examine the hardware, until I can greet the alien and admire his hat, there's nothing we can do. It's a dead end. Like, literally, I play this game. Every time you hear any news thing about UFOs, UAPs, just boil, compress down. Somebody saw a thing. You can just do it every single time. You can always just boil every single one of these things into somebody saw a thing. And they are all a dead end. Arjun, would these interviews have graphics to explain the concepts of the lesson? I'm not entirely sure they would be video. I'm sort of thinking making it podcast, like audio first, but that's more the easier way. Yeah. User 1990, his hat. Yeah, everybody knows that the best way to get on the good side of an alien is to compliment his hat. We talked about this earlier. Did you just join us? All right. DG, hello. What do you think about eclipses? I have my own theory, but I want to share yours. My theory? Eclipses are caused when either the moon's shadow falls on the Earth or the Earth's shadow falls on the moon. All right. That's my theory. Thank you for the donation, Nathan Conklin. All right. I think we reached the end of our show. Nancy, you want to help brainstorm the class thing? Sure. I mean, it's going to be like reaching out to 50 researchers who are experts in different fields. But we've got lots of names in our Rolodex already. So if you want to help with that, I am, so I don't have to. You're the right person for the job, man. It's you. For our hats. Our hats! Yeah. Okay. All right. Well, I'm going to wrap it up. So thank you, everybody, for joining me this week. It's always super fun to answer your questions live here on the YouTube channel. What have we got coming up this week? Okay. So the weekly Space Hangout, we have 5 more shows until our summer hiatus. So Dr. Mario Barunda coming up this week. We've got episodes of Astronomy Cast coming up on Friday. Again, 4 or 5 more episodes until we reach hiatus. This show is going to go on hiatus as well. So just remember that I won't be doing any more live shows after the end of June until the beginning of September. So 2 months off, July and August, which we do every year. But yeah, so put a like. I don't ever beg for likes, but go ahead, like the show, although it's going to disappear, so no one will ever see it. But hey, thank you, everybody, for joining me this week. Thanks to all the moderators. Thanks to Nancy. Chad, if you ever watch this, thank you. And we'll see all of you either later this week with some of the other shows we do, or I'll see you back here next week. Thanks, everyone. Now, where is the button? There it is.